Now we want to look at an example where we don't have the sample mean X bar. Instead, we're given a list of sample data values. So a lot of times this is where you're actually going to start with real problems is you have the sample data and you need to calculate that X bar value and proceed from there. So I've got information shared with you in the install and delays Excel document. And what this is telling us is that we know the installation of a certain computer hardware has a standard deviation of 7 minutes. So we're given the sigma value, but we don't know the mean install time. So we don't know mu. A technician installs this hardware on 50 different computers and records the times in the data set that we're given. We want to compute a 95% confidence interval for the mean install time. So 50 is our in value, our sample size. First of all, it says to check the conditions. Are we even able to create a z interval here? Notice that we are not told that the original population is normal. There's no information about that. But because n is 50, which is greater than 30, we still are okay here, or greater than or equal to 30. So even though we don't know the population distribution being normal, we don't need that unless the sample size is less than 30. So we're good. We've got our condition checked. The first thing we'd want to do is, like before, find that margin of error. In order to find that, we start with alpha, finding alpha, which is 1 minus the confidence level. In this case, that's 1 minus 0.95 for a 95% level. So alpha is 0.05. Notice that sigma we're given as 7 and n is 50. We can then use Excel to find that margin of error by using the same formula that we've already used in this section, by using confidence dot norm. And this takes the alpha, 0.05, comma sigma, which is 7, comma n, which is 50. And that will calculate our margin of error. So I'm going to go ahead and go over to Excel, and I've got an area for that to be calculated. So I'm going to type it in, enters or equals confidence. I have to type it correctly, and it populates. So I'm going to pick that confidence.norm, 0.05, 7, and 50. So that calculates the margin of error, and I'm going to keep 2 decimal places. I'm going to call that 1.94. The difference between this problem and the last problem is simply that we do not have that sample mean, that X bar value, so we also need to calculate it. But we know how to do that. We could just use the equals average command, highlight our data, and find it. So I'm going to do that over here in Excel as well. Equals average. And then I'm going to highlight my data set, all 50 of these values. Close it up. And it looks like the X bar value is 42.7. And now we have everything that we need to go on back here and calculate the interval, because we know that the intervals are created by doing X bar minus the margin of error for the lower limit and X bar plus the margin of error for the upper limit. So using the calculations we just did, this would be 42.7 minus 1.94, comma 42.7 plus 1.94. And calculating that out, we get 40.76, comma 44.64. So that's the confidence interval. And then the last thing we always want to include is an explanation and contextual explanation as to what this confidence interval tells us. So what this tells us is that we are 95% confident that, that's how these always start, filling in our confidence level. So we are 95% confident that what are we talking about? What is this population parameter that we're estimating? Well, it's the mean, it's time, right? Or the mean of all install times is between 40.76 and 44.64 minutes. And that finishes up the problem.